I equal to? What is angle R equal to? Because we know both of them are equal, and you also know that this normal forms a 90-degree angle with the plane mirror. Okay, I have actually given you guys a hint here. Okay, in the chat box, you guys are required to answer. On which one? The not on my full name, only Suhail. Okay, now not on Muhammad Suhail Khan. Okay, let me actually drop a message with this ID so that you guys will get that. Okay. The first law is clear to
So
all
we
three
need
of
to
you now.
find out like the right angle.
Yeah.
So first we need to like find the whole right angle.
Exactly. Exactly.
I mean like the whole reflected ray and like the incident ray.
First thing is that the hint which I will be giving here, that you guys know that normal forms a 90-degree angle with this plane mirror. This angle here will be 90-degree. Okay. So the thing here is that this, look at the arrow where I'm pointing here. Look at the pointer. This whole angle is 90-degree. This whole angle measures how much? 90-degree. Okay. And this much angle here has been 60-degree. This much is 60-degree. So you just need to find the angle of incidence, angle of reflection, what that will be.
Sir, I've sent my
Sundus, your voice is not audible. Sundus, your voice is not really audible. I can't hear you properly. Yeah, Sundus, please, will you please repeat?
Yeah, because of the network issues.
Okay, no issue.
Sir, can you hear me?
You are unable to solve. Okay, I will be explaining that. Okay, now don't worry.
Sir, it's because of network issues. Can you hear me?
Sundus, do one thing now. Just type it. Just type it in the chat box.
I can't type it because this is my brother's phone.
Okay. Then please speak that again. What you were saying.
No, sir. I mean,
Okay. Chakrika, I have received your answer. That is correct. Vaiga, what about you? Getting it? How we are supposed to do this?
No, sir.
Okay. No worries. Okay. The thing here is that, let me redraw the figure here. Or let's just do with this one. This whole angle will be measuring 90-degree. Right now, the measurement of this angle will be 90-degree now. Or let's just take a simple diagram, for example, here. So in those, I'm explaining this question. Okay. So we know that this much here is 60-degree and the whole angle measures 90-degree. So what about this angle here? So angle I, will it not be equal to whole of the angle minus 60-degree? That gives me 30-degree now. Vaiga?
Yes, sir.
Getting it now. Good. Sundus, what about you?
I can't type. I know the answer, but I can't type, sir, in this brother's
Okay.
mobile.
Okay.
Can you hear me?
Now I heard it properly now. Okay, good. So that is 90 minus 60, that is 30 degree. So if the angle of incidence is 30 degree, obviously as per the law, angle of reflection will also be 30 degree. Getting it? So both of it measures 30 degree and 30 degree.
Okay, sir.
So that was the first law of reflection, which basically says that the angle of incidence is equal to angle of reflection in a curved mirror, kya? Huh? Or in a plane mirror, right? And then under the bracket, you can denote it in this manner. Getting it? Okay.
Yes, sir.
And then we come to the second law of reflection. So second law of reflection, what does it basically says? It basically says that the angle of, sorry, the incident ray and the reflected ray and the normal. What rays? Suppose okay. So we have taken a plane, for example. I have taken a plane. All right now. I have taken a plane. Okay. And say angle is incident on this plane. Angle is incident on the plane, and then it gets reflected back. It gets reflected back, and then you will draw a normal line also. So let's draw that normal line also. So that is the angle of incidence. That is the angle of reflection here. This was the incident ray. This was the reflected ray. Let's name them incident ray, and then that is the reflected ray. Now, here what happens? Here basically what happens? If you were to place a paper here like this, let's place a paper over it in this manner. Okay, so that is a plane here. This so that here. Okay, why the pointer is not working? Anyways, it's not working. Okay, so what are we seeing here? That look at this plane here. Okay, and then look at this plane here. Okay, pay attention to this plane here. This plane here. Imagine that to be a sheet of paper, for example. Just imagine like this is a sheet of paper. Okay, na guys. So here you see that you have got the incident ray, and that is the reflected ray, and this normal. Can't I imagine that all these three lines, this incident ray, the reflected ray, and the normal, are lying on this paper here? It's not like this. Look, let me get an example here. For example, if I were to, let's say, have a plane like this, do tell me whether this is visible to you guys or not. Suppose this is the plane here. Guys, is this visible to all of you? Okay. Suppose this is a plane
Yes, sir.
over here, and then there is another plane over here. You guys know what is a plane now? What a plane means? Plane, what does it mean? That is clear or not? Plain, this plane.
So a plane basically means an object which has a soft, smooth, and like flat surface, right?
Plane. A plane simply refers to a flat surface. A flat surface. That is what a plane basically means. Okay. So imagine that you're having two flat surfaces like this. One like this, another one is like this. Okay now? And then you imagine, try to imagine it like the incident ray is falling over it. Okay. There is incident ray over it. Okay, incident ray coming from this direction, then getting reflected in this direction, and then you draw the normal line between the incident and the reflected ray. So what basically I'm trying to show you guys here, that all these three lines, are they not lying on this plane over here when they are getting reflected. Suppose this is the surface from where the reflection is happening. This is the surface from where the reflection is happening. Imagine that a light ray struck it and then it got reflected back. So far clear or not?
Yes, sir.
Yes,
Okay.
sir.
So I am saying that it's not. Yeah, I'm about to explain. Okay, now I'm saying that it's not like a light rays were incident on it in this direction and it went in that direction. No, it's not like that. It's not like that. Like light rays were incident on this plane in this direction, but it went in any direction on its own. Getting into what I'm trying to say here? It will exactly get reflected back from this plane in this manner. It will be coming in this manner and then get reflected in this manner. See if I can draw it using a piece of paper. Guys, just give me a moment. I will be back in a second. Now, let me get a paper. Okay.
Okay, sir.
Now try to visualize it. Okay, this is a plane, and then this is another plane lying over it. Is it properly visible to all three of you?
Yes, sir.
Okay. Now you guys can look. There's a incident ray which I've drawn on it. In the reflected ray, I represents incident ray. R here, inverted. It will be appearing as inverted R anyways. So that is reflected ray, and that is a normal. That is clear. Okay. So when there's a reflection of light rays from a plane, all the incident ray, the normal and the reflected ray, they will lie on a plane. Up, you guys can imagine like this is a plane on which all these three reflected ray, incident ray, and the normal is lying. Is the concept clear or not?
Yes, sir.
Chakrika?
Yes, sir.
So that is what basically the second law of reflection is all about. So how do we define that? Anyone? Try to define it in your own language. Yes? Anyone? Okay, let me write it. The incident ray, the reflected ray, and the normal, all and the normal to the mirror, all lie on in the same plane. In the same plane. Is the definition of second law clear or not? Yes? Guys, is the definition
Yes,
clear
sir.
to all three of you? Okay. Sundus, is that clear to you also? Okay. Now then we can proceed ahead then. Let's
No,
proceed.
sir. I am not clear. The network issues
Not
are
clear.
there and I don't understand a thing and I can't see.
Okay, okay.
Sir, I didn't understand.
Ah.
Yes.
Look here. Simple thing is now.
Can't even see you, sir.
You can't even see me.
For me,
Okay. Okay, she's really having a bad network. Okay. Anyways, in the next class, I will be explaining that to her. So just do one thing now. Okay, please get your network issue fixed. Okay. You won't understand the concept unless you are able to see me, unless you are able to see this picture. Okay now. So get your next network connection please fixed. In the next class, I will be sure explaining that again to you. Do remind me that. Okay now. Okay. Okay. Then let's move ahead then. After the laws of reflection, we did talked about the types of reflection, right? Like reflection does not always occur in the same manner. We did in fact talked about it. There were two types of reflection. One is the regular and the irregular. Another name for irregular reflection is also diffused reflection. Diffuse reflection. Now, Vaiga, will you please explain what were the points we discussed in the regular and the diffuse reflection? Quickly, we did discussed about the two in the previous class. Okay, do explain the regular and irregular reflection. You were present in the previous class now.
Yes, sir.
Mhm. So what were the points we discussed in the two? There was something like
Like in
parallel.
reflection,
Hmm.
like the light reflects in only one direction.
The another direction in the same medium, and they are also parallel to each other.
Yes, sir.
Hmm.
So
Yes.
can I also try? Because like
Yeah,
our ma'am
you can
already
also add
finished
points.
the lesson.
Yeah,
So,
you can
yes, sir.
also add points. Good.
Yes, sir. So in like regular reflection, the light rays like they fall on like a soft, shiny, and smooth surface, and then they reflect back. But then if the surface is like rough or like it's not proper as this before as the like regular reflection,
Hmm.
like this like the reflection still works and happens,
Hmm.
but then it's just that the surface is like different from the regular reflection.
Okay, surface is there. Surface is different. That is correct. Okay, but we need to define it in terms of reflection only. Okay, how reflection is being influenced due to the irregularities in the surface. Okay, for example, if the surface is regular, smooth, and shiny, then the manner in which the light rays are coming and then they are getting reflected, the manner will be in such a way that it will be following laws of reflection will be followed here. Laws of reflection will be followed, isn't it, guys? Okay, as you can see from the diagram itself. Second thing, you get to see that all the light rays that are incident on the surface, they are parallel to each other. These light rays are parallel to each other, while the reflected light rays are also parallel to each other. So that is what we get to see in the regular reflection, right? And also the are formed by images formed by the regular reflection is also sharp and clear. Sharp and clear, right? And then you have got the irregular reflection, where we can see actually we can see that the light rays that are incident on a irregular surface, they are actually parallel to each other. Okay, they are actually parallel to each other, but in which direction they will be getting reflected back, we don't know that. So thereby we see that the incident rays are parallel to each other while the reflected rays are not parallel to each other. Thereby here if you were to draw the incident ray and the reflected ray, here it will be something, here it will be something. Okay, the incident ray will be smaller, might be smaller, while the reflected ray will be more. So either incident ray will be greater than the reflected either the incidence angle of incidence will be greater than the angle of reflection, or we say that the angle of incidence might be smaller than the angle of reflection. Getting it what I'm trying to say here?
Yes, sir, got
Yes,
it.
getting it now. Okay. So
So
two
can you
things.
explain the point again, like the before point?
Yeah, two things needs to be taken care of in the case of irregular reflection. The first point is that although the incident rays are parallel to each other, incident rays, as you can see, they are parallel to each other right now, but the reflected rays are not parallel to each other. Then the second thing I say that when you will be plotting the normal at the point of incidence, this is the point of incidence. These are the incoming rays, and the one which I have shown with the black color here, the black line, that is the incident ray. And if you were to plot the angle of incidence, this angle of reflection for each of the individual incident rays. So thereby you will see that either angle of incident is greater than angle of reflection, or either angle of reflection is greater than angle of incidence. So these two things might happen here.
So
Is
these two things will only happen in irregular reflection, right?
in irregular reflection only right now. While the same thing, if you were to see in the case of regular reflection, incident angle, angle of incidence, and angle of reflection, all of them will be equal to each other. Getting it or not? Clear to all of you? Yes?
Yes.
Shall we move ahead then? Okay. Then we come to the spherical mirrors. Okay, we did talked about the spherical mirrors. Like, what are the spherical mirrors? So spherical mirrors are basically curved mirrors. It has the mirror which has the shape of a piece cut out of a spherical surface. For example, if I were to have a spherical surface like this, a complete spherical surface, right now, and suppose if I were to cut it into half, okay, I were to cut it into half. So thereby I will be getting two mirrors out of it. I will be getting two mirrors out of it. This part number one, or this part actually. So will be what? The reflecting surface is bulging outward here. Remember that.
Convex mirror, sir.
That will be a convex mirror, exactly. So you will be getting a convex mirror in this case. And now look at the another part of this sphere. That is this part. So here you will be getting this concave mirror. This concave mirror, where
Okay,
the
sir.
reflecting surface is inward. The inward side is reflecting side of it. Getting it or not? Look here. Let me repeat this again. Imagine you're having a complete sphere here, a spherical glass, for example, and if you have to break it into two pieces. So this half, where the now also remember why I have shaded this region, this part. Why I have shaded it? Because it is the back side of the spherical mirror. Reflection does not take place from the back side. Getting it? The light rays are falling from the front side. So this type of mirror will be called as convex mirror, where the reflecting surface is bulging outward. It's like this. Clear?
Okay, sir.
Then the another one where where the reflecting surface is bent inward like this. Bent inward like this. Like the spoon you see, no? Spoon, the front part of the spoon, how it looks like. So that can be taken an example of a concave mirror. Okay, not exactly, but you can take it as an example of a concave mirror. Concave mirror. So we can see that reflecting surface is bent inward, and here surface is bulging outward. Meaning of the words are clear now. What does bulge mean? What does bulging mean? Hmm?
Yes, sir.
Right. All right. So that is it about the two types of mirror. That is the concave mirror, and then you have the convex mirror. Okay, I'm not writing the definitions. You guys will have to write the definition in your own word. So what you will be saying, that if the outer surface of the curved mirror is painted, this one I'm talking about, if the outer surface of the plane mirror is painted and its inner surface is bent inward, then this type of spherical mirror is known as concave mirror. And if the inner surface of the curved mirror, look here, the inner surface of the curved mirror, you can imagine at this sphere. When I'm defining this now, consider that I'm talking about a sphere actually. Then the meaning of the inner and outer will be clear. So inner surface, this is the inner surface now. This that is the inner surface now. Guys, are you getting it?
Yes, sir.
And that is the outer surface now. So in the concave mirror, actually the outer surface is painted. That is painted. Okay. And then in the case of convex mirror, which part of the sphere is painted? Inner surface is painted, right?
Inner surface.
So if the inner surface of the curved mirror is painted and its outer surface is actually reflecting the light, actually it's a reflecting surface, then that type of spherical mirror is called as convex mirror. Any confusions? Yes,
So no confusions.
good. Then let's talk about the type of images formed by the two spherical mirrors. Let's talk about concave mirror first. Okay,
So it gives us real images, right?
concave mirror, yeah, it forms a real image. Getting it now? It forms a real image, right? So let's draw the concave mirror first. So concave mirror, and the surface is like this, right? The outer surface is it is painted, and that is the reflecting surface of it. Reflecting surface. Now talking about this concave mirror, it will form a image that is real, inverted, and will be larger than the object. What did I say about the property of the images?
It
First
forms a
thing is
real image
hmm,
and
Inverted image.
inverted image. Okay, have a look at this example here. That is a concave mirror which you guys are seeing here. Look at this. Okay, now. So look at the candle placed here. Look at this candle here. And look at the flame of the candle here. Does it not look opposite, inverted? Does it not look inverted? Shall I zoom it?
It does, sir.
It's inverted now. Yes, Viger.
no, sir.
No.
It's not inverted, right?
Yes.
Oh yeah, okay, so it's inverted.
Sundus. Or then, if you were to try obtaining the image of this plant outside the window or of this tree outside the window using a concave mirror. So the setup is such that you have placed a concave mirror, okay, at the window, and the reflected light rays coming from the tree, okay, will be allowed to fall on a screen. So on the screen you will be getting an image, but that will be inverted image. So you can do this activity actually. Have a concave mirror with yourself, okay, stand at the window and try to obtain an image of a tree on a smooth surface. It has to be a smooth surface. You can actually use a mirror or any other type of screen which is very smooth, but you will have to adjust the position of the mirror. Okay, it's not just like you went up with the mirror at the window and then you are complaining why I'm not getting the image. So you will have to adjust the position of the concave mirror. Getting it? Getting it or not? And then Inverted, that thing is clear now. Then I say that it's real
Yes, sir.
actually. Why real? Because you can actually obtain the image on a screen. This is the screen, and we were able to obtain the image. Here also we have obtained the image of it on a screen.
So,
Mhm.
so like basically, I don't get like the part where
Mhm.
I mean, in like convex mirrors,
Mhm.
it's like a virtual image, and like we cannot obtain a picture. Like, how is that possible? Like, I mean, I don't know if this example is like correct or not, but like I'm confused because like we
Mhm.
take selfies like in front of the mirror, like using the mirror. So it's like it's basically being captured on a screen, right?
Okay, look, that's a complete different technology, and thereby actually there are sensors that are working. Okay, if you were to look at our eyes, okay, thereby there also the image formation takes place at the back of the eye on retina. Okay, but then there also we get to see that we don't have such a screen placed at the back of the eye where an actual image is being formed. No, you guys know that whenever there's a thought process going in our mind, whenever you think of doing something, there are certain chemical reactions going on. For each thought, you can imagine certain impulses are generated, electrical impulses are generated in our mind. Okay, so
Yes, sir.
was there something real related to that? I mean to say that if you were to imagine that you are doing some particular activity, was that particular activity actually drawn on a screen on your brain? No. Then
No,
coming
sir.
to the
No,
uh,
sir.
then then coming to the part where Chakrika was asking in the phone. In phone, basically what is happening? There are so many sensors installed in the phone. So that is basically trapping the reflected light rays, studying that light rays, and then thereby displaying that image. Okay, right now. So there you don't have actually the what do you say, that since you have got the sensors basically installed there now, so that sensor is basically displaying the image on the screen. It's not like that the light rays that are falling on the camera, it is directly being displayed. Had it been like this, if you were to open your gallery anytime or open your screen anytime you flash the phone at any at a surface, at an object, you will be getting an image without actually clicking it. Getting it what I'm trying to say? Okay. Yes, I'm saying that basically,
Doesn't it say again?
yeah, I was basically saying that had it been following the simple laws of reflection, had it been following the laws of simple reflection in the manner like the light rays were getting reflected from the plane mirror here. Okay, getting reflected from the plane mirror here, and then you actually get the image of the photo on your screen, on your phone's screen. Thereby, basically, what is happening? The image that is being captured by the sensor that has been transported into the readable and viewable format here. There's not actual conversion of the light rays here. Had it been like that, so what will happen now? We know that the light rays that are passing from a magnifying glass, that all of it converges, and then you get the image of the sun on the piece of paper or whatever it is. But it does not occurs in the same manner in the case of a smartphone as well. Okay, now, so it is not as simple as that, right? Hope it makes sense to you guys. Hope it is clear, huh? Is that clear or not? Please let me know.
It's clear.
Yes, it's clear.
Yes,
Okay,
sir.
now back to what we were talking, that is concave mirror. So we consider the image formed by it as real image because it can be obtained on a screen. Can be obtained on a screen. Then I said that the image form is inverted. Upright, up, in what manner? Sideways inversion is there. or top to bottom inversion is there. Top becomes bottom or bottom of the object becomes top. In that manner, the
The
inversion
bottom
takes
of the
place.
object becomes the top.
Exactly. Or the top of the object might become its bottom. Either way you can say it, right? So image is real, inverted, and it is magnified also. It is magnified also. Getting it or not? Now, when the object is being moved really close to the mirror, if you were to move the image object close to the mirror, then what will happen? The image will be formed at that time also. That at that time also it will be erect, but then it will be virtual. What do I mean to say? I basically mean to say that if you were to bring this concave mirror very close to this tree, closer to tree, at that time when you will bring it closer to the tree, will you be able to get the image of the tree now on the screen? The answer is
Also, it will be like upright.
no. No, it will be
So
upright.
so basically we like the image will be formed, but then it'll be like an upright. It'll be in erect position.
It will be in erect position, and then it will be in
Virtual.
it will be a virtual image. You cannot opt in that on a screen. Yes, getting it or not?
Yes,
Yes,
sir.
guys.
Yes, sir.
Okay, now. So that is the interesting thing about the concave mirror. So condition applied is that when we bring the object very close to a, now here we were actually moving the plane mirror, this concave mirror, because we can't bring the tree closer to this a concave mirror. Now the object here is the tree. Object here is the tree. But since you can't uproot that tree now and then bring it to the
Sir, but
concave mirror,
then
that's why we're moving concave mirrors. Yes.
so but then it depends, right? Like for suppose the candle, as it is like
Mhm.
small, we can move it. So it basically
Exactly.
depends on the objects, right?
Exactly. It depends on the object. If you have got a small piece of object, you will bring it close to the concave mirror then. Yeah, good. So then the condition here is that when we bring the object very close to a concave mirror, then what happens? The image form is first erect, then virtual, then virtual. Right now? Hope it is clear to all of you. So that is all you need to remember about it, concave mirror. And talking about its uses, where do we use it? Now, you guys can, I
So
will
we
be
use
giving you a
it
hint.
in dentist, right?
Magnified image.
Like
Exactly. Since
yes,
it
right?
forms a magnifying, yes, that is correct. Since it forms a
So
magnified
what about
image,
like in
thereby it is
shaving
used here.
mirrors?
Shaving mirrors, that is also a concave mirror. The shaving mirrors,
And the
that is also a
magnifying
concave
glass.
mirror. In the
Magnifying
So
glass?
the
magnifying glass, that is a convex
uh,
lens, not a concave
are
lens.
the headlights of
Lens,
the
yes,
vehicle?
yes.
The
Headlights
headlights, yeah, that
of
is
vehicle.
not actually a mirror, but is having a concave like shape.
So,
Okay. Yeah.
so like, the mirrors like which we have in our cars.
Mhm.
Like
Yes.
suppose if there's like an ambulance and it is it is usually it's reversed in like reverse form, right? But when we see through a car mirror, we
Mhm.
can clearly see that it's ambulance because like our the mirror in our car is basically convex. Concave.
So it is written in the mirror, like objects in the mirror are closer than they appear. Have you seen that actually written on the side mirror, on the rear mirror?
No, so
On the rear mirror of the car, you will get to see that there's a text written on the mirror. Objects in the mirror are closer than they appear. Why is it so? For the convenience of the driver. so that a vehicle coming from behind of the car, the driver will be able to see it even if
It's
it
a
is at some
convex
distance.
mirror, right?
That is a,
Convex mirror.
you guys tell me what that type of mirror is.
It's a convex mirror.
Just give me a moment.
So
Yeah, sorry. Continue.
So like it's a convex mirror, right?
Yeah,
yes,
that is
sir.
a convex mirror. Exactly. Because usually convex mirror forms a what type of image? It forms a diminished and smaller images than the object size. Okay.
So
Mhm.
so but then like what about the one like which shows like the reverse
Which shows
or
the
like
reverse image.
yes sir, like I mean like basically it's lateral inversion of
Mhm.
like words. So
Yeah, just
suppose like
like you have got the
ambulance.
ambulance. Yeah.
Yes,
Suppose you
sir.
have got this ambulance here now. So thereby the letters are written in lateral inversion so that the vehicles ahead of it will be able to spell it
So
correctly.
sir, like is it because the type of mirror we have or is it because like of the lateral inversion?
No, it's because simply the phenomena of lateral inversion can be seen more properly in a plane mirror, right?
Okay, sir, it's a plain
All
mirror. So
plane mirror. Also, in
oh,
fact, you can view it in the case of um, this a convex mirror also. Okay, because convex mirror also forms erect images. It does not form inverted images.
yes,
Getting
sir.
it now? So
Yes, sir.
that is why convex mirrors will be fitted in the vehicles. So that is why the driver will be able to see the images of the vehicles coming from back of it. Okay, and also as I said that as we will be discussing about convex mirror, first discuss about it convex mirror, then the point regarding that will also be clear. Okay now. So that is what we were talking about, the concave mirror. Now let me just give a moment. Let me add a page, one more page. Yeah. Talking about the convex mirror. Okay. So the deflecting surface is inside. The inner surface is the painted one, and the reflecting surface is bulging outward. That is the deflecting surface, right? Okay. Here in the case of convex mirror, what happens? The images that are formed will be erect in nature. Images are erect. And second thing about it is virtual. For example, how it is virtual? Just another, let's again take the example of the sun. The sun's rays that are falling on this convex mirror, they will be converged to a point. They will be converged to a point. But do we actually see the rays as
Also,
converging?
the diverge, right?
No, in a convex mirror, the rays converge. They come to meet at a point.
Sir, it's in concave, right?
It appears to be converging. Okay. When you
No,
have
sir.
got a
In like
concave mirror.
concave mirror, like
Mhm.
it is all the concave mirror is also like known as like the converging mirror, and
Mhm.
then like the convex mirror is
It's
basically
known as
also
the
known as the diverging mirror.
diverging mirror. Okay, that is correct. Look here. If but it is in the sense. What do I mean by that? Look here. When the light rays are falling on this concave mirror, okay, they will be actually like this. They will be diverging like this and then come to meet at a point like this. They are actually diverging from a concave mirror.
So, but then as they hit the smooth surface, they immediately reflect back, right? Right? Would they go at the back of the mirror?
Exactly. Look here. it appears as if they are diverging from the back of the mirror. They will appear as if they are diverging, but then they will be combining here. And then look at the case of the convex mirror here. Okay, here it does not. Here it actually is. You can see it seems as if they are coming to meet at a point. Okay, now so the rays not actually looks like if they are converging at a point. Getting it or not? Yes.
Yes, sir, got it.
Yes.
Getting it now? Okay. Then again, we were talking about its property. The image form will be erect and it will be virtual. The third point about it is that
It's
it will be
diminished.
diminished. That is the reason why it is used in the rear mirrors. In the mirrors, that is why it is used in the vehicles, so that it will be giving the driver a large view area, a large area view. Getting it now? So the images formed by convex mirrors are erect, virtual, and diminished, and thereby these are used in the vehicles as it gives the driver images spread over a large area. So he was able to get image of a large area. Getting it now? Is that clear?
Yes, sir.
Okay. Now then, let's quickly summarize the difference between the real image and virtual image. An image that is formed when the light rays reflect and meet at the same point. That is a real image. While in the case of virtual image, it is formed when the light rays reflect and diverge from the same point. Okay. Then other points regarding real image, it can be viewed on a screen. It is always inverted, formed by concave mirror. Formed by a concave mirror, right? Then talking about the virtual image, it cannot be viewed on the screen since it is virtual, as the word says. It is always erect and formed by convex, concave, and plane mirrors, all the three types of mirror. While the real image will only be formed by the concave mirror. We will be discussing all these points with the help of some examples in the next